And so number 21 says your drawer contains 2 blue socks, 2 brown socks, and 2 black socks. Without looking, you pull out 2 socks. Draw a probability tree diagram. We'll use the letter E for blue, N for brown, and K for black. It says each time you pull out, or the first time you pull out a sock, there's an equal chance of drawing each color. So at the very beginning, there's 6 socks, and 2 of them are blue. So the probability of drawing out a blue sock the first time is 2/6, or a third. And the first time, there are 6 socks and 2 are brown, so there's a 1/3 chance that you draw out a brown sock. And again, at the beginning, there's 6 socks and 2 are black, so there's a 1/3 chance of drawing out a black sock. The next time you pull out a sock, there's only 5 socks in the drawer and only 1 sock left of the color that you pulled out the first time. So if you pulled out a blue the first time, there's only 1 blue left out of 5. So the probability of drawing a second blue sock is a 5th. And there's 2 browns, so the probability that your second sock is brown is 2/5. And there's 2 blacks, so the probability that the second sock you draw out is black is 2/5. If you drew out a brown one the first time, then there's a 2/5 chance that the next one's blue, because there's 2 blues left out of 5. There's a 1/5 chance that the next one is brown, because there's 1 brown left out of 5. And there's a 2/5 chance that the second one is black. If you pulled out a black the first time, there's a 2/5 chance that the next one is blue. There's a 2/5 chance that the next one is brown, and there's a 1/5 chance that the next one is black. Does that make sense so far? Okay, and then it says to list the sample space. So you could get both socks blue. You could draw a blue first and then a brown. You could draw a blue first and then a black. You could draw a brown first and then a blue. You could draw out both socks that are brown. You could draw out a brown and then a black. You could draw out a black and then a blue, black and then a brown, or they could both be black. Part C says list the event that you have a matched pair. So if you have a matched pair, you either have both blue or both brown or both black. Part D says, what is the probability of getting a matched pair? So for this one, we want to find the probability of getting 2 blue or 2 brown or 2 black. We use the additive property, and we can split that up into the probability that they're both blue, plus the probability that they're both brown, plus the probability that they're both black. And then to figure out the probabilities, blue, blue means first we got a blue, that's 1/3, and then we got a blue, that's a 5th. So we multiply a 1/3 times a 5th. And then the probability that they're both brown, we follow that path. So first we have a 1/3, and then we have a 1/5, so that's a 1/3 times a 5th. And then probability that they're both black, we follow this path to black and then black, and we multiply the 1/3 times the 1/5. So that's where these numbers are coming from. A 1/3 times a 5th is a 15th, so we get 1/15 plus 1/15 plus 1/15, and that gives me 3/15, which simplifies down to 1/5. Does that make sense so far?
Yes.
Part E. Okay. Part E says, what's the probability of getting a matched blue pair? So for this one, we just want to find the probability of getting blue and then blue. And that's 1/3 times 1/5, which is just a 15th. So we're doing blue, blue. Okay, and when we go through the tree, we just multiply those probabilities.